All right, hi class. Welcome to Motor Learning and Performance, PEP 288, with me, Elizabeth Harding. We are going to go over your Lab 1, and we are going to calculate error scores, as well as compare the three toss conditions. So we have toss condition 1, 2, and 3. And you were charged with calculating the absolute, constant, and variable error for each of these conditions. All right, but before we get started, I've arranged my sheet. This was the demo sheet that's in your Lab 1 folder in Learn. And you can see I have some UNM IDs here. The sex, height in centimeters, which I'm going to add. Height in centimeters, and weight in kilograms, as well as age and hand dominance. So the hand you would typically use to throw a ball. All right, so let's go ahead and do our participant demographics first. The first thing I want to do is I want to find out how many participants I actually have, or I guess how many participants' data I actually have to use in this analysis. Okay, so I'm going to use the count function in Excel. So that's just equals. Okay, so you can either follow along with me in this box here or up in this function line. So equals count, parenthesis, okay, and I'm just going to count by student ID, okay, and it returns 19 participants. Now keep in mind Excel likes numbers, so even though it's, this number is arbitrary because it's only counting, the actual rows of data, if these cells were to say contain names, like Bob and Sam and Sarah, it wouldn't understand that. So I just, fortunately, it's the ID number. So just keep that in mind. Now we're going to count how many men we had in our study. So equals, I'm going to have to use the COUNTIF function. Okay, so you see I have this column here. 1 equals male, 0 equals female. So I have these ones and zeros in this column. So I'm going to have to go equals COUNTIF, parenthesis, and then it says range, and then the criteria. So range is this entire column of data, and then the criteria that I'm looking for is a 1. Close the parenthesis, and there you go. So I have 7 males, and we're going to do the same thing for females. Equals COUNTIF, parenthesis, here's my range, okay, comma, and then the female was denoted by a 0. And there we go. So we have 12. So 7 and 12, 19, we're off to a good start. And now we have to look at hand dominance, right and left. So how many righties and how many lefties do we have in our study? So I'm going to also use the COUNTIF function. So equals COUNTIF, parenthesis. Here's my range, comma, and then I'm going to have to use quotation marks this time because, again, it doesn't necessarily like letters. It really likes numbers. So you can see I have quote R, unquote, because I used R's and L's to denote right and left-handed. Go ahead and close the parenthesis. And we have 15 right-handed individuals. So let's do the same with left. COUNTIF, parenthesis, highlight our range, comma, and then quote L, unquote, parenthesis. Okay, so there's our formula. Again, you can follow up here or down here, okay, and equals. All right, so we have 15 righties and 4 lefties equal to 19. So we're doing quite well. All right, so now let's go ahead and look at the average height, weight, and age of our participants. So for height, we're going to use average, parenthesis, highlight your column of data, and there you go. There's our mean height, weight, average, oh, that works. Okay, most recently used function, average. Here's my weight, highlight that, and enter. All right, so we have our mean weight. Now, because of the way that this is organized, as age is next to weight, I could actually just carry this formula over, and Excel will know to jump to the next column. So you can see I have an average age here of 22. Okay, so if you don't believe me, let's go ahead and take the average age and close the parenthesis. Don't really have to do that, but 22. Okay, so I'm going to delete this so you can see. Okay. So I had my height here and I wanted the mean or the average, right? So I can copy this formula over to the weight, 63.3 kilograms is the average and 22.0 years. All right, so now let's look at the standard deviation. We're going to use stdev.s. That S at the end is for sample. And we're going to take the standard deviation of the height. We're going to select the entire range of data. And we have a standard deviation of 10.1. Okay, what wouldn't work is equals stdev dot and then this number. So I've seen that mistake made quite often. It doesn't understand what you're talking about. It really needs the entire range of data because the standard deviation is really, you want to take the mean and then how far away are each of these values from the mean is a standard deviation. So it's individual, and so you need to take the individual data points equals stdev.s, and then here we go. Okay, and then we can do the same thing here. It knows to jump from this column to this column to this column and to use this formula for standard deviation. So we can just pull that across. Okay, so we have a standard deviation of 9.0 for the weight and a standard deviation of 3.1 years for the age. Right, so this is a nice little table that you could include in your lab reports. I'm just going to add a little outside border. So you would just copy and paste this right into your lab report. And then as far as the number of participants that you had, males, females, right and left, you could make a table for that or add it to this table, or you can just use that or write that into your text. Okay, so let's move on to the actual data. So what I gave you here, you were to enter your raw scores, say for TOS condition 1. Here's your raw score for the first trial, second trial, all the way to the 5th trial. And then what was calculated for you here was the absolute error. So let's go ahead and just do that. I'm going to go ahead and get rid of all of this. Clear content. So I'm rocking a Mac right now. It's a little different than a PC. So equals absolute, just ABS, okay, capitals, not capitals. It understands, and then I'm just going to highlight that one cell, because I'm looking for the absolute value of trial 1 under TOS condition 1. There we go, and we have a 13. And that makes sense, right? Make sure you just kind of check. All right, so now we know that we had 5 trials, so we could actually pull this right over, and Excel's going to jump the columns for us. And there we go. Does that look right? I think that looks pretty good. And then if we just click, okay, let me see if I can. So I have my plus sign here. My cursor is turned to a plus sign. And I get to this little end, see that little square in the box? So now my plus sign is turned dark. If I just quickly double click, it goes ahead and fills it in. Alternatively, you can just pull. Okay. All right, so there is your absolute error. Do a really quick check, make sure there's no negative signs. There should definitely not be negative signs in your absolute error. All right, so now let's look at the average absolute error for the 5 trials for each participant. So we're just going to take equals average, and we're going to take the absolute error scores only. So this absolute T1 all the way to absolute T5. And hit enter. Okay, so same thing, you can drag all the way down or just quickly, just depending on your machine and how quick you are. Okay, so absolute error. Now constant error is a little different. Constant error takes direction into consideration, and so we want to use our raw error scores. So these are the scores that you're measured for you. Okay, and remember, a negative implies that you undershot the target, and a positive value implies that you overshot the target. Okay, so we're going to take the average here. All right, equals average. And then these first 5 scores, there we go, okay? And then we can carry that down. And then variable error is the standard deviation of the raw error scores, or constant error. So equals stdev.sample, because remember, we're making an inference about a population using a sample, so that's why you have this little s here. And then and take this, the first 5 values again, and there we go. So that's the variable error. Okay, so we talked a little bit about significant figures and digits of precision in class. We're just going to go ahead and leave it alone for now. And then when it comes to actually making our table and reporting our results, we're going to want to take these down a little bit, only because we used a tape measure, and that tape measure was only really accurate, so long as your vision was accurate, to 1/16. Okay, so we only really get about 2 digits of precision. Okay, so 1/16 is about, was that 0.06? So we don't necessarily want to get a little bit beyond what our original measurement tool was. Okay, so we can definitely take two digits after the decimal point, but probably no more. Okay. So the rest of this is done for you. You can see my variable error is way out of control here and all the way over. All right, so now that we have that, let's go ahead and do some analysis. So I'm just going to switch worksheets here. Okay, you might recognize this from lecture. All right, so I have toss condition 1 and my absolute constant variable error. Toss condition 2, same. Okay, and I made a series of graphs. We talked about maybe which graph would be the best option. But let's go ahead and just fill in this table, and we'll see the graphs go ahead and start to fill in. All right, so let's take the mean absolute error for toss condition 1. So that's going to be equals average here. Highlight your range of data. Okay. And then let's go ahead and do the standard deviation while we're at it. Okay, now the way that it's arranged, right, it's all in line with, here's toss condition 1, constant error, variable error, right? So as long as everything's in order, we can just move our formula across, and we should get, if we wanted to check this variable error, let's look at our formula. It's the average of J3 to J21, and we're certainly in J. Here's our first cell full of data is J3. Last cell in that column is J21, right? So we can see and go backwards and see that our formula definitely copied over and into the right place. Okay, so same with standard deviation. Just go ahead and take that, pull that all the way across. Okay, and just really quick check. Yep, looks good. Yep, looks good. All right, and so you can see that my graphs really started to take shape here. Okay. So the reason why these tables, and you have these arrows just in case you forgot, was this table, if you were to just highlight, and actually let's go ahead and do that. I'm going to take this away. You might regret that, but let's just go ahead and take that away. I want all of these, I guess I want all of this in my table. So I want to know the difference between toss conditions. So I definitely want these labels in there. I want my headers that say absolute and constant and variable error. And then really you're only asked to graph the means and the standard deviations, but we're going to use our standard deviations as the error bars. So instead of worrying so much about this row here, this row 27 that has our standard deviation, we're going to highlight rows 24 to 26, okay, just to the column J. So we're just going to highlight this data right here in this box. And then if we go to Insert, Column Chart, oh, where'd it go? You can see that it clearly, wow, that's interesting. Okay, hang on. Okay. Should probably select a cell. Sorry about that. It didn't really know where to put it. So I just commanded Z, and you can see my sheet's kind of back to where it was when I fully deleted my my graph, or my chart. Sorry, my chart. All right, so now I have a cell highlighted. I want my chart in this area. So insert chart. Yes, we want a column chart. Here we go. Oh, okay. Seriously? And one more time. So I guess I need to highlight this data. There, okay. Sincerely apologize for that. There we go. All right, so you can see I just highlighted the mean, didn't worry about the standard deviation, and now I have absolute constant variable error for my 3 trials. Okay, a couple things that I'd like you to do to clean up. We don't necessarily need this little series marker for this particular chart. Okay, so we have 3 graphs on one chart. And we're going to get rid of that header just because I don't particularly care for that either. Okay, so we have all of our absolute constant variable error scores for TC1, all of them for TC2, and you can see constant error is very low for that toss condition 2, and then toss condition 3. Okay, so a way we can clean this up is we can actually make them different colors, so you can just highlight individually. Oops. Okay, so I just double clicked on this absolute error here, and I'm going to format it, format data point. I'm going to fill it, and I'd like to fill it with, say, a nice dark blue. Okay, so then I would want this to be absolute error. For each one of these, I would actually want to go along and go ahead and fill them in. Okay, and that can be quite cumbersome, right? So each absolute error would be represented by a different color, etc. All right, so let me show you how to insert error bars. So you can see we have our variables lined up here along the x-axis, and it matches very close to what we have going on over here in our data table. So I'm going to right click. See, you can see each column is highlighted, these little circles right here. And I'm going to not do that. I'm going to keep that highlighted. I'm going to go to chart layout. Oh, sorry. Wow, I am out of control. All right, chart layout. And I would like to add error bars. Now, some of you might be using a newer version of Excel, and so or even a PC, which would have, add chart element. And from there, you would probably somewhere over here, you would just go to add error bars. So I'm going to use this drop-down menu here and go to error bar options because I want to use the standard deviations that we actually calculated. So here's my error bar menu. I'm going to go custom. I want to specify the value. And it's going to give me positive and negative, right? So standard deviation is plus or minus, 6.01, plus or minus 5.96, right? So I'm going to highlight, for the positive values, I'm going to highlight this standard deviations. And I'm just all of them because it's actually going to match it up based on the arrangement up here, right? So this will be the absolute error standard deviation for toss condition 1, the constant error standard deviation for toss condition 1, right? So as long as it knows, or as long as it's in order, it will follow right along. I actually don't necessarily want to use negative error bars because it's just going to clutter up the graph or the chart. So I'm just going to see what happens if I were to just leave this alone. And so it just kind of gives me the positive values. I particularly like caps in the plus side only. Let's see, we got custom, we're looking good, and then hit OK. Let's see what happens. Yeah, there we go. And so now we have some really nice error bars that, you really see a lot of variability between the participants and between the participants for each of the conditions, right? And so that actually makes me think that we're probably not going to see anything really significant. Okay, our differences weren't that huge in order to see significance, especially with so much variability between participants. So that's how you would add error bars. Coming down, we kind of agreed that maybe this wasn't the best visual representation of our graph, but we do have this guy right here, right? And so remember, you have your independent variables. So your independent variable is the one that you manipulate, right? So it's the condition in our case, right? And then the dependent variable is the score, right? So the score is dependent on the condition. And so typically our independent variable goes on the x-axis and our dependent variable goes on the y-axis. And so to me, this just makes it like, here's our conditions. Our conditions are the independents. And then we have this series key right here that blue is absolute, orange is constant, gray is variable. See, in this case, you would want to go ahead and keep the key. And you can see I've just gone ahead and added my error bars, and I used them from right here. But just to show you how you have to do that, here is the table set up, and this is just means. To get something like this, it's not as easy as up here where we can just highlight the standard deviations all the way across and Excel knows where to put them. And the reason is because when I highlight, right, it's only highlighting the absolute error for the three conditions. So I need to choose the absolute error for toss condition 1, toss condition 2, toss condition 3. So you can see what I have here. I have absolute error toss condition 1, absolute error toss condition 2, absolute error toss condition 3. All right, so let's see if we can do that relatively efficiently. Okay, so I'm going to go back to chart layout. Where are my error bars? Here we go. I want error bar options. Custom, specify value. Okay, so we're only using positive, and you can see I hand selected. Here's this right here tells you what worksheet I'm using. You can see I'm using analysis 2, cell B27. Okay, so we have cell B27, right? And then I did a comma, and I selected here AE, and here AE. So let's go ahead and see if I can replicate this. Okay. All right, here we go. So I am going to click on this first absolute error. I'm going to hold down my control or command key and select this one, and control or command, just depending on if you're using a Mac or a PC, and hold down that one, and let's see. Yep. And we're just going to hit OK. I definitely want to cap in the plus side only. Cap, plus, good to go. Right. And it does. It looks actually quite similar to what I had before, so actually it should be exact. But that's how you would do that. Is just you would go through and so for constant error, make sure you highlight the data that you're interested in, right? So the orange is constant error, so go ahead and click on it, and you can see even that little guy right there. Oh, you guys did so good on that particular condition as far as constant error. You can see all just the constant error is highlighted. Okay, so then you would go up to your chart layout, your error bars, error bar options, because we want some custom job right here, specify value, and then let's go ahead and get rid of this. Okay, so go ahead and select constant error for your toss condition 1, and then go ahead and hold down the control key, toss condition 2, and toss condition 3. Okay, and then just keep in mind, just so you can do a very quick data check, look at the standard deviation here. It's 10.9 versus say 5.29 in toss condition 2 for constant error. So hopefully our error bar is a little more than twice this length here. Okay, and that's kind of a check so we can see, okay, yeah, we did that right. Plus side only and style cap. Again, if you're using a PC, you're not necessarily going to have, it'll probably be a lot easier. All right, so let's take a look at this graph. Chart. I always get that confused because we have multiple graphs on the same chart. Yeah, look at that, right? So that looks definitely a little bit more, it should just be about double what this one is. So now we've definitely created this very custom option for error bars. And then if you look at variable error here, right, they're kind of almost the same size, but that's okay. I might want to go through, let's go ahead and do that one more time just to make sure. I'm going to go and highlight chart layout, error bars. It's funny, no matter how many times you do something, sometimes you still get lost. All right, here we go. Yeah, I think for some reason this was only selecting that one cell. So this is a great example. So now we can select variable error for toss condition 1, hold down the control key, toss condition 2, toss condition 3, right? So look at our individual cells are highlighted. Cap style looks good, only the plus side's good. Okay. And we should have a few custom, yeah. It's a little, actually, it looks pretty similar, doesn't it? Well, that's okay. I trust it just a little bit more. All right, so there's your, I think this is a great graph to use for your lab report. Just a couple things to clean up. I absolutely can't stand chart titles. We just don't use them. This would be considered a figure. You'd want to put a nice little informative caption underneath your figure. So you don't really need to title anything. But one thing that you do need is a vertical axis title. So let's go ahead and add that, because I don't want you to forget that. Because people do need to understand, what is that measurement? Did you measure in centimeters? We measured in inches. So go ahead and use this to see. We're going to say error score, and then we're going to say inches. Okay, and there you go. So we could probably make that a little bit bigger. Just this is kind of the fussiness of making pretty charts. Okay. All right, so I think that looks really good, and then you could go ahead and just copy and paste that into your lab report. But if I had gone with the negative, you can see how long this one is here, or even this one. It would have definitely cluttered up, the chart. These boxes probably would have gotten very small. You would have had these long black lines. It would have looked very confusing. So I think just keeping it on the positive side as far as your error bars is a good idea in this case. All right, so now let's look and see if we have any significance. So we are going to do the Excel t-test, or the t-test in Excel. So you can see I've made a table here. I have absolute constant variable error. So I'm going to compare toss condition 1 to toss condition 2, toss condition 1 to toss condition 3, and then toss condition 2 and 3. All right, and the formula, I'm just going to go ahead and get rid of these so we can do a demo. So I want to make sure that I know where my TC1 data and TC2 data is, but you need to just be aware that you need to select the entire range of data. Okay, so we're going to go equals t dot test, and then it's giving you a clue here. So it's saying array 1, which is going to be our absolute error scores for toss condition 1, comma array 2, which is our absolute error scores for toss condition 2. And then we're doing a two-tail t-test. So if you remember from statistics, you have this nice bell-shaped curve, right? Well, we want both ends of the test to be represented. And then the last thing is type. And we're doing a paired t-test because it was the same participant completing both TC1 and TC2. Okay, so now if it was two different participants, like you had a control group and an exercising group, you would do an independent samples t-test. And that type here in Excel would be type 2. Okay, so we're gonna run a type 1. So I'm gonna select my first range, which is the absolute error for TC1. So I'm gonna select that data. And I know the formula, I know it's a comma. Okay, so you can follow me up here. And select this next row of data. Okay, comma. We know that I want a two-tailed t-test, and one is for paired samples. Okay, so, and then enter. Oh. Okay, so apparently I got something stuck in there. There we go. All right, so for the t-test, for absolute error, I have a p-value. So the student's t-test, students was actually a guy's name, it returns the p-value. Okay, so the probability that the results you're seeing are actually due to something, right? Not just a chance. And so the alpha level here was set at a 0.05. So anything over, equal to or over 0.05 is not significant, right? And I have a 0.33, so that's not significant. All right, so let's go ahead and repeat this for constant error. Equals t.test, parenthesis, let's go back to constant error, select our entire range of data, comma, tc2, comma, two tails, type 1. And there we go. So 0.3, not significant, right? So variable error, t.test, select the entire range for TC1. Don't forget your comma, and TC2, comma, two tails, 1. Okay, so not significant. And so you're going to do the same for your data for toss condition 1 and toss condition 3. Right, you can see that I've just gone ahead and done this here. And then just to point out, so my results, I had a 0.05, which in some cases, some might say, well, it's approaching significance, right? It's not less than 0.05. So it's less than 0.05 we could consider significant. Greater than or equal to 0.05 is not significant. So it's close, but not significant. So in this case, I would report that there was no significant difference between toss condition 1 and toss condition 2. I'm sorry, toss condition 2 and toss condition 3 regarding constant error. And in this case, there was no significant difference between absolute constant variable error for any of the tossing conditions. Right. So that should get you through at least the analysis part, or at least get you to where you can visualize and analyze your data for your lab report. If you have any questions, go ahead and email me, and keep an eye out for a video on how to organize your data, right? So how to download the sheet from Google Sheets, and then go ahead and put it into a nice chart where you can easily access everything and it doesn't look like complete chaos. All right, but that should definitely help you with Lab 1. All right, take care.